Let's balance a few more chemical equations. And as I do this is going to be up in the ante a little bit. I want to start out with just the names of some elements or compounds and come up with what we're going to make. So you may want to get a hold of a periodic table to look at as we're doing this. So let's say we want to react some yttrium with some fluorine. And let's try to predict what we're going to make. So yttrium is element number 39. It's in group 3b. Fluorine is element number 9. It's in group 7. Now, one thing to note, if we're doing a chemical reaction between these elements, if we find fluorine in nature, it always comes as a diatomic molecule. It's always F2. So these molecules are diatomic molecules in nature. Hydrogen, nitrogen, oxygen, and the halogens. Fluorine, chlorine, bromine, and iodine. If you come across these as elements in their pure form, they're always going to be diatomic molecules. So we're going to make some sort of yttrium fluoride compound, Fluoride. So yttrium, we said, is in group 3. It wants to get a +3 charge. Fluorine becomes fluoride, in which case each one has a -1 charge. And so to make this electrically neutral, we're going to write in this subscript. Now, we're not starting out with the compounds with all the formulas to begin with. Well, if we do that, you can't go changing subscripts. We're trying to come up with the original subscripts as we work in these types of problems. So this is an okay thing to do. So the correct formula from yttrium fluoride is YF3. Now we need to balance this chemical equation. 1 yttrium, so far so good. 2 fluorines, 3 fluorines. So let's do the crisscross applesauce trick. Let's put a 3 in front of the F2 and a 2 in front of the YF. And so see what we've got. So now we've got 6 fluorines on the reactant side and 6 fluorines on the product side. We've got 2 yttrium on the product side. To make the reactant side balance, we've got to put a 2 in front of the yttrium. And so now everything's balanced. So that's how we go about making yttrium fluoride, and we could call this a combination reaction. Now let's do sodium plus oxygen. Figure out what we're going to make. So sodium is Na, and oxygen is O2. It's one of that list of diatomic molecules that we find in nature when we find these particular elements. And we want to make some sort of NaO compound, sodium oxide. So we need to come up with what the subscripts are for this sodium oxide. Sodium is element number 11, so when it makes an ionic compound, it's going to have a +1 charge. Oxygen is in group 6. It's going to have a -2 charge. And so to write the balanced formula for sodium oxide, it's going to be Na2O. I've got 2 times +1 is +2 for my sodiums. 1 times -2 is -2 for my oxygen. So my charges balance give me this neutral compound. So that's the correct chemical formula for sodium oxide. But we want to balance the chemical equation. 1 sodium on the left, on the reactant side, 2 on the right, on the product side. I need a 2 in front of the sodium. 2 oxygens on the left, Oops, I've only got 2 oxygens on the right. So I need more oxygens on the product side. Let's put a 2 there. So now my oxygen's balanced, but my sodiums no longer are. I've now got 2 times 2 is 4 sodiums on the product side. So that means I need to change that 2 in front of the sodium on the reactant side to a 4. So now I got 4 sodiums and 2 oxygens. 4 sodiums and 2 oxygens in this combination reaction. And all is balanced. Let's do one more word problem, writing the chemical equation from it. Let's do the combustion of butane. The combustion of butane. Butane is C4H10. It's a hydrocarbon. It's also an alkane. And when it's an organic compound, when you combust those, you're going to burn it with oxygen. And the products are carbon dioxide and water. So let's balance it. 4 carbons on the left, and we got 1 on the right. So that means on the product side in front of CO2, I need to put a 4. I've got 10 hydrogens on the reactant side. Right now, I've got 2 hydrogens with water, so we'll put a 5 in front of that. So now I got 4 carbons and 10 hydrogens. I've got 2 oxygens on the reactant side. I've got 4 times 2 is 8 oxygens plus 5 oxygens. That's 13 oxygens on the product side. So I can balance that by putting 13 halves in front of the O2. So now I've got 13 halves times 2 times O2. That gives me 13 oxygens. And so everything is balanced. If you don't like the half, and a lot of times you won't see a half as part of a coefficient in chemical equation, you can multiply everything in the reaction by 2. So now I've got 2 C4H10 plus 13 O2, because 13 halves times 2 just gives me 13, reacts to make 8 CO2 plus 10 H2O. So let's check our atoms. In the butane, 2 times C4 is 8 carbons, 2 times 10 is 20 hydrogens, and 13 times 2 is 26 oxygens from my O2. Product side, 8 carbons from the carbon dioxide. I've got 2 times 10 is 20 hydrogens. And if I do my oxygens, I got 8 times 2 from carbon dioxide, that's 16, plus 10 from my water, that's 26 oxygens. So everything balances. And so this video is looking at taking words, writing chemical equations from the words, then balancing those chemical equations.